how can you grow rocks from thin air? Giant icicles of rock, like this, or this. And how do you do this? Oh, look at this. If you've ever been to or seen pictures of a cave underground, then you may well have seen these icicle-looking things hanging down from the ceiling. And they are stalactites. And stalagmites are really just the same thing, but sticking up from the floor. I find the easiest way to remember it is that stalagmites are mighty enough to hold themselves up, whereas stalactites, they hold on tight so they don't fall down. So how big can they get? Well, my friends, I have scoured the globe from the tallest mountain to the deepest cave to bring you the absolute biggest tites and mites that there are. So firstly, the largest solo standing stalagmite can be found in Cuba, and it is a whopping, are you ready, 67.2 meters tall. Now, that is the same as 15 double-decker buses stacked one on top of each other. It's the width of a football pitch. It is half the height of a great pyramid. You get the picture, right? But if we look at clusters where a bunch of mites all stand together, shoulder to shoulder, we can find one that is a little bit taller. The very tallest is in Vietnam, and it's officially 3 million years old. And height-wise, it stands at just over 70 meters tall. So what about stalactites that dangle from the ceiling? Well, to be honest, these can't quite grow as large because if they get too big, they just tend to fall off. Right now, the longest freestanding or free-hanging stalactite is in Brazil, and it hangs at 28 meters. So that is as long as a swimming pool or 5 times the height of a giraffe, just hanging from the ceiling. I would not stand underneath that. If we think about the Vietnamese and Cuban stalagmites, when they started growing, us humans hadn't even evolved yet. Our ancestors were basically hairy apes. If one had started at the time when the Romans were around, so 2,000 years ago, it would now be 20 centimeters big. That's not massive, is it? But what about one that started growing, let's say, 100 years ago, so when the TV was invented? That would be 1.3 centimeters big. Pretty small. So that just shows you how slowly stalactites and stalagmites grow. But I am an impatient lady. So I have come up with a way to grow a stalagmite almost instantaneously using this stuff. This is sodium acetate solution, and it's not something you can do at home. And to use it, I'm going to use my goggles and my gloves. And what I'm going to do is I am going to pour it onto my cave floor. Let's see if we can grow a stalagmite instantaneously. Okay, let's give it a go. Up it goes. Oh, come on, how tall can we get it? Keep on going. Oh, it's not as easy as it looks. Oh, look at this. What's that? That's like 25 centimeters. This is looking rather good. Nailing this. I'm quite impressed with that. That is an instant stalagmite. If only the real ones were that quick. So how do they get so big? Do they just grow out of thin air? No, they definitely do not. They actually grow from drips of water. So how can water grow huge rock structures? Well, it's because the water in caves is slightly acidic. So as it moves through the rock, it reacts with the rock and dissolves it into the water. And then as the water drips down from the cave, it leaves the rock behind. And bit by bit, the stalactite will grow. And I'm going to show you how this works. So how something seemingly disappears into water and then can come back out of it again. So it's like magic, but science, so better. This whole process works because rain can be acidic. And here I have some acid. It's a much stronger acid than rain can be, which is why I'm wearing my goggles and my gloves. And here I have some limestone rock. And if I drop that into the acid, we can see that it's reacting with the acid. I could drop some more on top like this. It's fizzing away there. And if I left that long enough, it would completely disappear. And this is what is happening inside caves. That acidic water is reacting with the rock and in essence dissolving it and then carrying it through the cave. And then, under the right circumstances, the water will evaporate and leave the rock behind. And I can show you that using this spray here. Let's just get rid of this acid. Now this spray, believe it or not, has a mineral dissolved in it. In our case, it's salt, but obviously in caves, it's rock that is dissolved in the water. And if I spray this onto this hot plate, we'll speed up that evaporation process. And then we should see our rock, our salt, coming out. Let's give it a go. You can totally see that as the water evaporates, it's leaving behind these solid deposits. You see this? That is our rock. And this is how layer by layer stalactites and stalagmites are made. Let's go back into our cave and with the water dripping down from the ceiling. So how do you go from this to this? So in a cave, drip by drip, rings of rock form around each water droplet. And you guessed it, over time, these build up and up into a tube-like structure until you end up with one of these hanging from the ceiling. Now, these are called straws or soda straws, and they're the heart of stalactites. Now, if the end of the straw gets blocked, then the water ends up dripping down the outside and so deposits its rock there instead, turning one of these into one of these. Now you might think that these look like icicles, which you've seen before, and yes, you are right, they can be considered the same thing. In icy caves, you have water that freezes as it drips down from the ceiling to form huge ice spikes. And you can even get ice stalagmites that grow up from the floor. And you can get stalactites made from lava. When, after a volcanic eruption, molten lava drips down from the ceiling of a cave or off a ledge, and it forms all manner of shapes as it cools. These ones are known as shark teeth stalactites. And we checked all of these out, but none of them are quite as big as the big ones we just showed you. So there you go, that was my instant stalagmite. And to be honest, it was much better than I thought it was gonna be. It looked quite beautiful, but it is nothing compared to the real thing. If we just let science get on with it, then the results really are spectacular.